Ang pag-uusapan naman natin ngayon is about temperature. Well, first of all, it is important na malaman natin na magkaiba ang temperature and heat. Heat is a form of energy, while the temperature is not. It is measured in calories or kilocalories. And when we say calorie, it is the amount of heat necessary to raise the temperature of 1 gram of water 1 degree Celsius. To be precise, it is from 14.5 degrees Celsius to 15.5 degrees Celsius. Heat is the transfer of energy between systems that are at different temperatures. While temperature is an objective measurement of how hot or how cold an object is. It is a means of determining the internal energy contained within a given system. Technically, it is defined as the average energy of the molecules in the system. Well, itong difference ng temperature and heat will be more discussed when we reach to thermodynamics. But we will give you some idea para magkaroon kayo ng overview kung ano ba yung kaibahan ng temperature and heat. And this can be discussed in kinetic theory, especially for fluids and gases. Well, imagine that we have a balloon occupied by gases. Well, yung gases na nasa loob ng balloon natin are in continuous motion. Let us say that these are the particles inside the balloon. Well, if we apply heat into the balloon, according to kinetic theory, the greater the amount of heat is absorbed into the material, the more rapidly the atoms within that material begin to move. And the faster the atoms move, the more temperature increases. Therefore, it means na kapag nag-increase tayo ng heat, yung mga particles natin ay mag-move faster. And actually, these movements ng mga particles na nagbabound sa walls ng balloon natin, that makes up the volume ng ating gases sa loob ng balloon. Therefore, mag-i-increase ang volume natin sa loob ng balloon. And this is also what is expressed in Charles' law pag nakarating na tayo sa gas laws natin. According to Charles' law, the initial volume over the initial temperature is equal to the final volume over the final temperature. In which, kapag in-isolate natin yung final temperature, ito magiging equation natin, which means, kapag nag-increase itong ating volume, mag-i-increase din itong ating temperature. And also, as atoms begin to slow down their movement, the material becomes cooler. Things get a little more complicated for solids, of course, but that's the basic idea. Therefore, kapag ang movement ng mga particles natin sa loob ng ating balloon ay bumagal, our temperature will also decrease. And as we define it, temperature is a measure of the average energy of the molecules in the system. So, it is the measure of the internal energy ng ating system. So, that's the basic idea, no? So, dyan makikita natin ang pagkakaiba ng heat at ng temperature. Now, let us talk about temperature scales. Ito naman yung mga units na ginagamit whenever we are measuring temperature. We have what we call the Celsius, Fahrenheit, Kelvin, and the Rankine scale. Yung Celsius at yung Fahrenheit scale ang tinatawag nating relative scales. And yung Kelvin and Rankine ang tinatawag nating absolute scales. Relative scale is a system of measurement that begins at some point selected by a person and can progress in both directions. While the absolute scale is a system of measurement that begins at a minimum or 0 point and progresses in only one direction. Well, ipapakita natin itong iba't ibang temperature scales natin and then i-explain natin uli itong relative and absolute scales kapag meron na tayong presentation. No? For now, let us proceed. Ang device na ginagamit natin to measure temperature is what we call a thermometer. And as you can see, dahil meron tayong iba't ibang temperature scales, thermometers are also devised in different scales. But we will present this with a story on how this temperature scales has been developed. So as you can see, all these 4 temperature scales are named after famous physicists or scientists. But actually, none of them had invented the thermometer. The first recorded use of thermometer is with Galileo Galilei, in sometime around 1603. And as per the record, ang ginamit niya to measure temperature is what they call the thermoscope. Well, it is not clear if this device is made by Galileo Galilei himself or ipinagawa niya rin sa iba. But since then, marami nang gumamit ng iba't ibang klase ng thermometer using different scales. And then here comes a German scientist named Daniel Gabriel Fahrenheit. One time, binisita niya yung kaibigan niyang si Ollie Romer. At doon niya nakita na itong si Ollie Romer ay gumagamit ng thermometer having a scale of 60. Itong scale na ginamit ni Ollie Romer na 60 is nakabase sa time. Because as you can see, time is scaled to 60 minutes, 60 seconds. No? So, why not use 60 in temperature? Yung 0, according to this scale, is based from the temperature of ice, salt, and water. But then, Fahrenheit thinks na itong scale na to is masyadong strict dahil from 0 to 60 is masyado siyang maliit. So, he devised his own scale and increased it to 240 scale. And the reason why he chose 240 is still unknown. So, putting this to our illustration, ang 0 degree Fahrenheit is based sa temperature ng ice, salt, and water. And then, Fahrenheit set the temperature of human body to 96 degree Fahrenheit. So basically, ito yung naging basis ng temperature scale ni Fahrenheit. And from this scale, lumabas that water freezes at 32 degree Fahrenheit. And it boils in 212 degree Fahrenheit. And then, another scientist named Under Celsius thinks na itong scale na to is not easy to apply. So he devised his own scale in which he set the freezing point of water at 0 degrees Celsius and boiling point on 100 degrees Celsius. Where according to the story, it is not originally like this. Ang unang device na ginawa ni Celsius is having the boiling point of water at 0 degrees Celsius and the freezing point at 100 degrees Celsius. And then later on, these units has been interchanged. And because of this 100 unit scale, it was initially called a centigrade. But then it was further agreed to name it under Celsius. Another gentleman from France named Guillaume Amontons mentioned na meron daw absolute zero. But unfortunately, at that time, he was ignored. Until William Thomson, also known as Lord Kelvin, introduced this concept. And he set the absolute zero as 0 Kelvin, in which, according to his experiments and data, it falls on negative 273.15 degrees Celsius. So from 0 Kelvin up to the freezing point of water, it is 273.15 Kelvin. And water boils at 373.15 Kelvin. Another absolute scale is introduced by William John Marcoin Rankine, in which he set the absolute zero in 0 Rankine, which is equal to negative 459.67 degree Fahrenheit. And from this scale, the water freezes at 491.67 Rankine and it boils on 671.67 Rankine. As you can see dito sa ating presentation, yung ating relative scale na tinatawag nating Fahrenheit and Celsius ay merong mga negative values in which according to our definition, it can progress in both directions. So from their 0, like for example, yung 0 degree Fahrenheit, it can progress in negative direction and can also progress in positive direction. Ganon din yung ating degree Celsius, it can progress in negative direction and it can also progress in positive direction. Samantalang itong ating absolute scales, it only progress in one direction. Nagsisimula siya sa 0 and progresses upward. And by the way, there are no temperature recorded na mas mababa pa sa temperature na 0 Kelvin. It is not possible to get a temperature lower than 0 Kelvin. So, paano nila nakuha itong value ng absolute zero natin na to? Which is equal to negative 273.15 Celsius. We are going to discuss that later kapag dating natin sa absolute temperatures. But for now, we are going to show you how to calculate the relative temperature scale conversion. So, ito yung formula na ginagamit natin to convert from degrees Celsius to degrees Fahrenheit. So, degrees Fahrenheit is equal to 9 over 5 times the degree Celsius plus 32 units. It can also be written as degree Fahrenheit is equal to 1.8 times degree Celsius plus 32. Now, in converting from Fahrenheit to Celsius, our formula is degree Celsius is equal to 5 over 9 times degree Fahrenheit minus 32. Which can also be written as degrees Fahrenheit minus 32 over 1.8. Well, para madali siyang matandaan, you can just remember this circle. So if you have a temperature given in degrees Celsius, you can just multiply it first to 1.8, then add 32, then you will get the degree Fahrenheit equivalent. Kung meron ka namang degree Fahrenheit na given, you have to subtract 32, then divide it to 1.8, then finally, you will get the degree Celsius equivalent. So let us do some sample problems para makita natin kung paano siya ginagawa. Problem number 1, the normal body temperature is 37 degrees Celsius. What does this read on Fahrenheit thermometer? So ang given natin dito is temperature which is equal to 37 degrees Celsius. At ang hinahanap natin is yung temperature expressed in degree Fahrenheit. Okay, so gamitin natin yung formula natin in converting from degree Celsius to degree Fahrenheit. We have F is equal to 9/5 times C plus 32. Well, para hindi tayo malito, lagyan natin ng degree symbol. Okay? So, degree Fahrenheit is equal to 9/5. Substitute natin itong ating temperature, which is 37, plus 32, which will give us a final answer of 98.6 degree Fahrenheit. Now let's go to the second problem. Convert 68 degree Fahrenheit room temperature to degree Celsius. So magko-convert naman tayo from degree Fahrenheit to degree Celsius. So ang formula natin, degree Celsius is equal to 5/9 times degree Fahrenheit minus 32. Okay, so substitute natin yung mga value natin. Degree Celsius is equal to 5/9 times degree Fahrenheit, 68 degree Fahrenheit minus 32. So this is equal to 5/9 times 68 minus 32, which is equal to 36. Then our final answer is 20 degrees Celsius. Okay, so kagaya ng nabanggit kanina, ang pag-uusapan naman natin ngayon is absolute temperature. Well, ano nga ba yung absolute temperature? Well, balikan natin yung balloon natin kanina. On this balloon, it is filled with gases. And the gas particles are moving around and bouncing on each other and the walls of the balloon. And as I mentioned earlier, itong mga movement ng particles na nagbabounce sa walls ng balloon, that is actually what's making up the volume of the balloon. So again, let us imagine that these are the particles inside the balloon. So the faster the movement of the particles inside the balloon, the higher the temperature. Ayan yung binanggit kanina natin sa kinetic theory. Therefore, the slower the movement, the lower the temperature. Now, according to this concept, kapag binababaan daw natin yung temperature, bumabagal din yung movement ng mga particles. So, ang question natin ngayon, since bumabagal yung mga movements ng mga particles natin, will there be a temperature kung saan totally hihinto yung movement ng ating mga particles? So, let's say, ito yung mga particles natin ngayon na huminto na ng movement. So, dito sa ating assumption ngayon, we are telling that all particles movement will stop. And also, a sample of gas would not take up any volume. Kasi, sabi natin kanina, ang nagmi-make up ng volume is itong mga movement ng particles na nagbabounce sa walls ng ating containers, no? So, since there is no movement ng ating mga particles, there will be no volume. So, at what temperature this will happen? So, ipapakita natin ngayon yung experiment na ginawa that reached to the absolute zero. So, let us have this graph. And we will show how the experiment has been carried out. So, let's say na nag-prepare sila ng sample of gas na may volume na 100 ml, no? And they set it to 200 degrees Celsius. So, nakikita natin dito, no? Yung first dot natin, ito. It is set on 200 degrees Celsius and 100 ml. So, yung unang test natin, ginawa natin at this point. And then what happened? We cool it down. Binabaan natin yung temperature to 150 degrees Celsius. And then, they measured the volume at nakita nila na bumaba rin yung volume natin, no? So, it now reached to, let's say, 90. And then, binabaan uli natin yung temperature to 100. At ito naman yung naging graph niya. And then, we proceed in lowering the temperature, then measuring the volume. And now, we reach to negative 150 degrees Celsius. Now, let's say, nung dumating na tayo sa 150 degrees Celsius, hindi na natin kayang i-proceed pa yung testing natin. Well, merong mga possible reason bakit hindi natin siya pwedeng i-proceed. One possible reason is yung gas natin is probably magli-liquefy. Dahil as we reduce the temperature, maaring mag-condense yung gases natin. So, let's say on 150 degrees Celsius, nag-condense yung gas natin. So, hindi natin may proceed yung ating test. Because what we would like to find out here is anong temperature kung saan ang volume natin is magiging equal to 0. Ito yung hinahanap natin, no? Yung volume natin naging equal to 0. Dahil yung mga particles natin nag-stop na ng movement. So, yan ang hinahanap natin. Kaya lang, hindi natin ma-proceed yung ating test kasi maaaring yung material natin is not capable to achieve yung napakababang temperature. Or pwede rin na wala tayong sufficient device or equipment na makaka-achieve ng temperature lower than negative 150. That's a possibility. But we can still see what is the possible temperature that will produce 0 volume para sa ating sample. First, igagraph natin itong mga nakuha nating data. They notice that we are getting a straight line here. Now, in order to get the temperature at which the volume will be equal to 0, we can apply mathematics, which is what we call extrapolation. So, in extrapolation, i-extend lang natin itong graph natin to predict kung ano magiging value niya as we go on sa ating procedure. No? On this case, ito yung naging temperature kung saan na-reach natin yung 0 volume. Okay? So, for now, let's just mark it that way. No? Now, nagtest sila ng another sample and this time with lower volume. So, they put it in 200 degrees Celsius and with initial volume na mas mababa kaysa nung una. And then, ginawa uli nila yung procedure kung saan nagtest tayo every temperature and what is the corresponding volume. At ito yung nakuha nila. So, again, pwede nating i-graph yan and then extrapolate natin. And we don't know how many samples they did, but they have done several samples with different volume. They graph it and then they extrapolate. Ngayon, nakita nila that this is leading always to the same point. And this point is equal to negative 273.15 degrees Celsius. And this is what they called the absolute zero. And as we said before, the absolute zero is equal to 0 Kelvin. So this is the temperature where all particles will stop and the sample gas would not take up any volume. And also take note that up to this time, there is no scientific record na na-reach na tong absolute zero. And also take note that the average kinetic energy is directly proportional to the Kelvin temperature scale. So let us continue our discussion about the temperature conversion. So natutunan natin itong formula natin in converting from degree Celsius to degree Fahrenheit. At ito rin naman ang ating formula in converting from degree Fahrenheit to degree Celsius. To convert from Celsius to Kelvin, we are just adding 273.15. And in converting Kelvin to degree Celsius, we are just subtracting 273.15. Now about Fahrenheit and Rankine, in converting from degree Fahrenheit to Rankine, we are just adding 459.67. And in converting from Rankine to degree Fahrenheit, we are just subtracting 459.67. And by the way, when we are using absolute temperature, we are not writing the degree sign. We only use the degree sign for the relative temperatures, the degree Celsius and the degree Fahrenheit. And then again, let us do some sample problems para may apply natin itong ating mga formulas. Problem number 1, a man visited the doctor and had his temperature checked. The thermometer reads 37 degrees Celsius. What is the temperature in Kelvin? So we mentioned that in converting temperatures from degree Celsius to Kelvin, we are just adding 273.15. So our formula is Kelvin is equal to degree Celsius plus 273.15, which is equal to, Kelvin is equal to, our given 37 degrees Celsius plus 273.15. So our final answer here is 310.15 Kelvin. So this is our final answer. Now let's go to problem number 2. Silver melts at 1234 Kelvin and boils at 2483 Kelvin. Express these temperatures in degrees Celsius. So in converting from Kelvin to degrees Celsius, we are just subtracting 273.15. So ang formulang gagamitin natin is degrees Celsius is equal to Kelvin minus 273.15 units. Okay? So unahin natin itong melting point ng silver, which is 1234 Kelvin. Okay? So degrees Celsius is equal to Kelvin minus 273.15. So degrees Celsius is equal to 1234 Kelvin minus 273.15. So ang final answer natin dito is 960.85 degrees Celsius. Okay, so this is our final answer. Okay, next is yung boiling point, which is 2483 Kelvin. So our formula is degrees Celsius is equal to K minus 273.15, which is equal to 2483 minus 273.15, which is equal to 2209.85 degrees Celsius. And this is our final answer. Then we'll have another problem, problem number 3. The coldest days in Metro Manila were recorded on February 4, 1987 and on December 30, 1988, when the temperature plunged to 15.1 degrees Celsius. Convert the temperature to Rankine. So in order to convert from degrees Celsius to Rankine, kailangan i-convert muna natin siya into degree Fahrenheit. So ang formula natin dito is degree Fahrenheit is equal to 9/5 degrees Celsius plus 32. So degree Fahrenheit is equal to 9/5 times 15.1 degrees Celsius plus 32. This is equal to 59.18 degree Fahrenheit. Now we need to convert this to Rankine. So our formula is Rankine is equal to degree Fahrenheit plus 459.67. So we'll have here Rankine is equal to 59.18 plus 459.67, in which our final answer will be 518.85. So this will be our final answer. To watch more of our lecture videos about engineering and STEM subjects, please subscribe to our YouTube channel and click on the notification bell para lagi kayong updated sa mga videos na i-upload namin. We are regularly uploading tutorial videos in engineering, mathematics, chemistry, physics, at iba pang subject na magagamit ninyo sa inyong pagre-review. So, thank you very much sa patuloy ninyong pagsuporta sa enginerds.org.